I'm reminded of Heisenberg. He said, stop thinking about what a thing actually is, right? Because maybe we cannot know that, right? Like if I say, what is the trajectory of an electron, you will not be able to tell me that because it fundamentally is a fuzzy cloud of probabilities. If you say that there is a certain aspect of non-absolutism there, right? It is also about how we handle it, right? And in that way, we can say that the universe is actually quote-unquote pranking us. We have an anything goes, kuch bhi chalega type of attitude. Then obviously we're not talking about society in the practical sense, right? Because then I would as much go and do something violent, essentially, and be justified in doing so, right? So there is a certain boundary that we have to draw when it comes to ethics, maintaining the order of society, of nature, of universe. How do we practically do things in a certain manner? This us versus them dynamics, this is representing a very primitive, right, way to segregate these two as different divisions altogether, right? But in reality, society can never be just these two by themselves, right? So non-absolutism would give you the courage to have this conversation between these two sides. Namaste, welcome to another sit-down session of Sangam Talks, and today again we are fortunate enough to have Dr. Mrittunjoy Guha Majumdar among us, and without, we have introduced him many times, so today's topic is a very interesting topic, what start from his first book, Shiva to Schrödinger, and now in his fifth book, he again astonished us with his latest book, The Universe is Pranking Us. And the title itself is very interesting, sir. So let's start with that. The universe is pranking us. What is the deepest ontological assumption about reality that we continue to mistake for truth? Or did the idea, the name, emerge from a single conceptual anomaly? Your way of working, it's deeply intuited in this field, so you must know very well, or maybe it's a recurring thing you've seen in your experiments and all. Right. So thank you. Thank you for introducing the book as well. And so the book is actually a revelation that has happened over time, right? It wasn't a lightning bolt moment. It wasn't a eureka moment in that sense. But over time, when we try to understand how nature is, right? How the world, the universe is oriented, we see that there are many kinds of doubts that come into the picture, right? I mean, when we are children, for instance, we see a lot of things. We see the stars, we see things around us. As a child, I, for one, was very fascinated by this concept of iridescence of oil slicks, right? So when oil is on the ground, you see that it gives these rainbow patterns, right? So it's almost like the rainbows have come onto the ground, essentially. And it's a beautiful kind of conception in that sense. So the idea that rainbow should not be in the sky, but in the ground, is an interesting kind of manifestation of where a child may start having some doubts as to why this is happening, right? And when we are looking at physics itself, we see that we try to think of nature of the universe as very predictable, as very deterministic, as having a solid ground, essentially, on which things are built. Until, and that is the important bit, that this belief starts weakening one point at a time, right? So there are a number of different reasons why that belief weakened over time. So the first reason I would say, which I look back at the history of science and modern science, and there was a very famous experiment in 1887, which was by Michelson and Morley. And what they were trying to see is whether light, when it kind of is transmitted on the planet, on the Earth, through a certain kind of experimental setup, whether it moves through something known as ether, right? The concept of the ether. So the ether is a concept that was there in the Western parlance, in the Western metaphysics and science for a very long time. And the idea is that it's a very universally spread out kind of fluidic medium, if you will. And they tried to track that if the light is sent on the planet in the direction of rotation and perpendicular to the direction of rotation of the planet Earth, whether there will be a difference in the path length, the optical path length of the two different tracks, right? And there were certain considerations that they looked at, and they found that they did not get a trace of ether,
right? So it was kind of like a shocking kind of incident, because till that point it was assumed that there would be some degree of, ethereality, if you will, right? And so it's almost like you're going through riding a bicycle, right, through the wind, and you are changing your speed, let's say, but you're not feeling a change in the wind on your face, let's say, right? So that means that the wind is not even there, essentially, right? So anyway, so ether was kind of dismantled by Michelson and Morley.
They can't even fathom that any wave can propagate through without any medium.
Well, yes. So for the longest time, they were not kind of able to understand that without the concept of ether, right? And so this result just sat there, essentially, right? In 1887, things were still very classical, as we call it in physics. It was following Newton's laws and, the different aspects of mechanics, of gravity, of thermodynamics, for instance. And a little while later, like about, 20 years or so later, the gentleman, the very well-known kind of, personality in the world of science, by the name of Albert Einstein, came about. And he tried to look at this problem, or not exactly directly this problem, but he tried to look at some of the fundamental assumptions of that period, right? He tried to look at the idea that what if this concept of light, right, the speed of light, is constant for everyone in the world, in the universe, right? Regardless of if you're moving or not moving, right? We all know that when we talk about something moving in front of us, if we are also moving along with it, let's say, or we are moving in the opposite direction, the motion of that body is accordingly changed, right? So if you're moving with the same velocity as that thing out there, then we will see that thing as being still, not moving at all, essentially, right? But what Einstein said is that the velocity of, or the speed of light, right, remains constant regardless of the frame or the reference frame that you're talking about, right? So using that, there are various things that he started to develop, essentially, right? And one of the key ideas that came, obviously the main primary idea that came about, was that of special relativity, right? His theory of special relativity. And in fact, I always tell my students and others as well, that modern science is about repeated dismantling of various assumptions and theories of old, right?
Depostulate that.
Depostulating of sorts, right? And that's a very, powerful thing in itself.
Why should be the speed of light be absolute?
Right. So there are questions of that kind. But before that, Newton's laws were there for about 300, 400 years. And in 1905, which is called as Annus Mirabilis, the year of the miracles, Albert Einstein published 4 papers, right? So he published his paper on relativity, special relativity, on mass energy equivalence, which is E is equal to mc square, right? We have all read that on T-shirts and in popular culture. And then you have Brownian motion, right? And then the fourth one was the reason he got the Nobel Prize, which is the photoelectric effect. And so Einstein, in a way, with his photoelectric effect, he brought about the quantum revolution. And with the relativity-related papers, he brought about the relativistic revolution of sorts. Now, why is relativity so strange, right? So relativity says that there is no concept of a global clock, right, for instance, and time as well is actually frame dependent, right? So till now, we always thought about it in this way, suppose I, got up in the morning, right, and I see 9:47 on my clock, right? I like to think of the universe as having a certain clockwork mechanism of being, essentially, right? So the planets are moving according to my clock, essentially, that kind of a thought. So Einstein said nothing doing, right? That is not how it works, right? So you have this concept that time, the clock itself, is dependent on the frame in which the clock resides, right? So your clock and my clock, if you are moving relative to me, may not be giving the same time periods, essentially. So the idea of the relativistic clock, so there could be events where one thing is happening at the same time. Let's say 2 events are happening at the same time in your frame of reference. It may just happen that those 2 events are not happening at the same time for me, right? It could be that one of the events is actually happening before and the other happening after, whereas for you, it may be happening simultaneously, right? And now this is a very strange thing to say, right? Because there are 2 lights, for instance, and they are blinking together, right? You would expect that any frame of reference, they should be happening at the same time, right? But that is not always the case. And that's a beautiful and a very powerful, very counterintuitive result, right? The same thing also applies, or a similar thing applies to the concept of length as well, right? So there is a very famous experiment, a thought experiment, that let's say there is a certain kind of train, right? And the train is moving through a shed, right? And the shed has a shorter length than the train, right? And so the shed has a forward door and a back door. And in one frame of reference for the person standing on the ground, because of the motion and various other considerations, it may just happen that both the doors can be shut together on the train, even though the shed is shorter than the train. Right? However, in the case of the person in the train itself, they may not see it happening together. Right? So now, if the train is longer than the shed and the shed doors are shutting together, how do you reconcile that? Because you are basically fitting in something longer in something shorter and saying that it has fit in perfectly. Right? So this concept of time dilation and length contraction, as it is called, is a very fundamental concept in relativity as such. Right? Now, that is all physics, right? So in the 1930s, 1930-31 essentially, we also saw that in mathematics, right, things were also seen to be fairly strange in their own ways, and there were certain kind of thinkers, right? Hilbert, there was Gödel, Kurt Gödel, whom I'll be talking about shortly, and various others who were kind of thinking about these aspects, right? And so even Turing and Church Turing thesis and all that came about a little later, and so on and so forth. But Kurt Gödel gave a very interesting thought, right? That any mathematical theory, right, always has some truths, some statements, some propositions, which cannot be consistently proven with the axiomatic premises or the elements which are present within the system itself, right? So it is kind of, there are always certain cases, right, which just cannot be explained in terms of premises or elements within the system itself. So in a way, we are saying that there is no proof that exists within the rules per se. Right? And so even in mathematics, we see that there is a certain kind of aspect of limits, right? Now,
as a student, I must address Lagrange as well. Maybe not in the same context.
Sure. Yeah. Right. So, but you know, this is not a new concept though, right? In Western parlance, there was a figure by the name of Zeno, right? So Zeno of Ilia, as he was called, and he gave a very interesting kind of paradox, right? He said, we have all heard the story of the rabbit and the tortoise, right? The rabbit and the tortoise race, right? So, I mean, in that case, obviously the rabbit is very arrogant and he kind of, meanders around, and then the tortoise just wins the race. But what if the rabbit actually pursues the tortoise, right? So the idea was that if the rabbit pursues the tortoise and reaches the point that the tortoise has reached, then by that time the tortoise has gone a little ahead, right? The next time, again, the rabbit reaches the point the tortoise is, but the tortoise has again gone ahead. So in a way, the rabbit never quite catches the tortoise, right? But that's a paradox, because we do know that in an actual race, if the rabbit is really running, right, it probably will kind of catch up and probably defeat the tortoise as well in the race itself, right? So what exactly is happening? There's something strange happening. So the point is, in all of these things that I've spoken till now, there is a certain element of strangeness, a certain element of wonderment, of things being counterintuitive, right? We have an intuition of things. Hame lagta hai ki ye cheez aisa hona chahiye. We visualize it in a certain way, but it actually turns out to be very different from that, right? There's another very interesting kind of, paradox called the Sorites paradox, right? So the Sorites paradox says that when you are collecting different grains of dust or sand, right, and you're piling them on top of the other, one grain by itself is never a pile per se or a heap, right? What is the point at which the heap becomes a heap, right? Because if you keep on adding one grain at a time, right, the conception of a heap does not quite come about so naturally, right? Because a particle is not a heap, right? And there's no kind of relevance of a heap with it, right? You can also talk about the ocean, for instance, right? Boon boon se sagar bharna, right? Now the thing is, the concept that, yes, we do know that obviously the drops make up the ocean, but the oceanness and the dropness of it, right, are fairly not easily reconcilable with each other all the way, right? So Sorites was trying to say that no single step of moving a grain, as additional grain onto the collection, makes the single heap, right? So how do you talk about the heap when we are not able to reconcile it with the concept of each addition of the grains onto this so-called heap, right? So, however, things became very strange when Einstein gave us in 1905 the photoelectric effect and the idea of the quantum, right? But in 1911 and to 1927, there was a huge confluence of ideas. A lot of ideas came about in what we call as the quantum physics, the quantum theory, right? So quantum physics is actually came from 1905, even earlier. Max Planck was, he gave the Planck's constant in 1900, and there onwards we had a lot of developments. But in 1911, the Solvay conference, there was the first Solvay conference was organized, and a lot of questions of classical physics were fundamentally questioned, right? That maybe the way we are looking at nature, right, the way we think that things are the way they are, that's not quite true, right? And so the questions had started. And in 1927, which is one of the most well-known Solvay conferences, and there's a very famous picture, I mean, you can show your viewers as well, where the who's who, very famous minds, 15 Nobel laureates sitting all together, right? So they talked about the various questions that the quantum theory was having, right? So now they saw that in the world of the smallest of particles, things were very different from the physics that we see around us, right? So physics we see around us has a lot of determinism, right? We know what are the states of a system given the initial conditions and some laws, some rules, right, of how the system evolves, right? So you have the laws of motion, for instance, in mechanics and so on and so forth, right? Now, in quantum mechanics, it was seen that you had this concept of probabilities, right? This concept that if you did the same experiment multiple times, you will not necessarily get the same outcome, right? You will get different outcomes in different cases, let's say. And the idea is that, why is that the case, right? Because if you do the same experiment in the same conditions, you should have the reality of that whatever you're doing replicate. It should repeat after in each of the runs of the experiment. But in quantum physics, we see that that is not the case, right? So there are many other aspects also, for instance, that of superposition, right? A system can, so this is actually to do with superposition itself, but you also have things like entanglement, which is basically this concept that things can remain connected to each other regardless of how far apart they are in space, right? So the properties are in a way connected in terms of a non-trivial correlation, as it is called, right? So that correlation aspect is very important because in classical physics, we see there is something known as locality. Locality means if I am sitting here, there's an object in some point, it can only affect the things nearest around it, in the local proximity, the vicinity of it, right? But what if I say that a thing here can affect something on Pluto, or rather not affect, but it is connected in its properties with something on Pluto, right? You would say, ye to bada vichitra sa cheez hai. This is very weird to talk about, right? But in quantum physics, we do see that certain kinds of such connections exist, right? So the whole world of quantum physics and the world of superposition and entanglement was very, very different from the world that we see around us, right? Now, does that only relate to quantum? Not really, right? There are also cases where classical physics as well has something known as chaos theory, right? Chaos theory. So the idea is that given different kinds of initial conditions, you can have very different kinds of outcomes, right? And these outcomes can be fairly non-linear, as it is called. Non-linear mane, ek bahut chota sa effect somewhere can actually have a massive impact somewhere else, right? And there's a very famous butterfly effect that we talk about, that a butterfly flap here, obviously, kind of affects or causes a typhoon in Texas, right? Now, it is very difficult to reconcile that again, right? Because how does that thing affect the other thing at all, essentially? So there is also this idea that you have a lot of aspects which are non-linear. And then finally, you have something known as Chaitin's omega, right? Which is also a very interesting kind of aspect, which has to do with computation, right? So there is a problem called the halting problem, when you have to halt a certain program. Now, the way that is halted, the probability of that halting has to do with something known as the omega number. Right? There is something called as the omega number, which Professor Gregory Chaitin, who actually has endorsed this book as well, has given to us in the past. And there he says that the determination of the numbers that are comprising the omega number itself has a randomness associated with it, right? So you can never clearly know exactly, right, what would be the composition of that omega number, right? There is a certain degree of randomness that exists, right? So in all of these paradoxes, in all of these strange things, right, what is kind of connecting them, right? Because it often looks like each of them, if taken alone, they feel like exceptions, right? So the idea that your time is not absolute, right? The idea that truth is not always kind of provable, essentially, which Gödel told us about, right? Then that observation is not passive. In quantum mechanics, we say that the way the system evolves has a lot to do with how the observations have been done on the system, right? Then that reality is not fully deterministic, right? And then finally, that separation is not as clear as it seems, that there is more to it than just that, right? These all concepts, if taken by themselves, sound very, very exceptional, sound like the anomalies, essentially, right?
But I believe there is one catalyst to gain the momentum for the scientists to make those huge, new theories come.
Right.
So the industrial revolution is going on.
Yeah.
And there was the time for the great wars also.
Yes.
So the entropy, the concept of heat and thermodynamics, entropy thing is also
yes. In a way, that's interesting because Kirchhoff and Boltzmann, they were very early pioneers of thermodynamics. And Ludwig Boltzmann in the late 1800s, he gave this idea that things can come in packets of various properties, discreteness in energies particularly, and that is where the idea of the quantum or packets of energy first came about, right? So Kirchhoff's theory and Boltzmann, right, had a lot of things to contribute,
and you
in the
need
direction
to be
of
determined
that,
when it's come to industry.
Yes. However, the thing that I really admire about Einstein, and I think we have mentioned this in the past as well, is the courage that he had to say that maybe nature doesn't have a certain template as it was at least understood till that point. Maybe there are things which are very, very different that we have to admit to, essentially, right? So the idea that why does this part not fit the model? Right, there's this question, right? Whenever you see something new, ये इसमें क्यों नहीं बैठ रहा है ठीक से, right? Instead of that, what if we say that the model itself is too simple? And the model itself is incomplete. The model itself has aspects of nature it is just not covering, right? So Einstein made that big leap saying that we will not explain this whole idea of discreteness of energies. There were a lot of experiments that were happening which were showing this. He said, what if nature itself has different entities as discrete packets of energies, right? So light is not radiating discrete energy, but light is composed of the discrete packets of energy, which are called photons, which we know about, right? So that jump was a real shift, and even for me, right, when I was studying and exploring the whole world of physics, of course, that the universe didn't suddenly change per se, right? We just realized that it was not as solid and straightforward as we had assumed, right? And it has a straight-jacketed aspect, right?
Yet the great mind like Einstein, failed to fathom and got in a quarrel almost.
Absolutely. In fact,
with Bohr,
which is a very valid point. So 1927 to 1935,
what happened there?
8 years, there was intense debate between Niels Bohr and Albert Einstein on the idea that whether nature is probabilistic, it is working on chance, likelihoods, or is it deterministic, right? So Einstein somewhere did not like this idea that things are based on chance, right? They say that he said this whole quote, which is God does not play dice, right? Niels Bohr said nothing doing. There is a probabilistic aspect, right?
And there is one story about Madame Curie. How come she split the atom with an electron?
Right. So there were various discussions at that point. And then 1927 1935, 8 years of intense debate went on. And in 1935, Albert Einstein with Podolsky and Rosen gave the idea of entanglement in a very early form. And it is funny because Einstein actually wanted to disprove quantum theory. Okay.
Yes.
Or rather not disprove, but he wanted to show that quantum theory is incomplete, right? And he spoke about this idea of hidden variables, right? This very mystical, beautiful idea that there are some variables out there which we do not have access to. And because we don't have access to them, the things are probabilistic, right? The moment we get access to them, right? वो चाबी मिल जाए हमें उस चीज का, it will become deterministic in nature, right? Now, from 1935 to 1964, the debate went on still. Einstein had passed away by that time. He was very upset till the very end, essentially. And there are newspaper clippings, various people, And but to be fair, he was giving valid points in his own right. And obviously, he was the person who revolutionized the whole of physics, right, as we know it. But anyway, so the point is that then 1964, John Bell came and said, no, nature is fundamentally probabilistic in various ways at the quantum level, right? So this idea that things are very, very not quite that simple, right? And they are quite non-linear at that. I think in our Bharatiya Gyan Parampara, for instance, in our Indian traditions, we have had that thought in a different context, right? So when we talk about Vedanta, for instance, right? Vedanta has always said that there is a certain kind of empirical truth, right? And there is a more fundamental truth, right? Vyāvahārika Satya and Pāramārthika Satya, right? So the idea is that Vyāvahārika Satya is where you have empiricism of the physical world that we see around us. And it has a lot of contradictions, it has a lot of paradoxes, right? Which arise when we are trying to approach this idea of the absolute truth. Right. So these are two very kind of structured, and they have been discussed about in many places. In fact, in the Vedanta Dindima, right, by Acharya Narasimha Tirtha, he talks about this very interesting thing about adhyaropa, right, and apavada, right. Adhyaropa means that you superimpose something on something else, right, and apavada is basically to try to systematically negate it, essentially, right. So you first impose something, superimpose something, and then you negate it, right. It's a very interesting adhyaropa apavada, right, and the idea was that there is a paratantric, or there is this concept of swatantra. Swatantrata we know, right? Swatantrata is freedom, right? To be what you are, to have agency, essentially. But in the Vyāvahārika Satya, whatever is in Vyāvahārika Satya, it doesn't quite have that swatantra nature, the swatantrata, essentially. It has a paratantra nature of sorts, which is reliant on something more foundation, right? That is what Acharya Narasimha mentioned, right?
For an uninitiated, it will be like, make up your mind. Are you pranking us?
Right. So what is happening, right? What is happening? But for a scientist, unfortunately, they don't talk about the Pāramārthika Satya still, right? In most places, they would say that is more of speculative, ideations, essentially. But people are working in that end as well, right? Now, the other instance, the other treatise that comes to mind is Yoga Vāsiṣṭha, right? Yoga Vāsiṣṭha is the place where Acharya Maharishi Vāsiṣṭha and Sri Ram had a beautiful dialogue about consciousness, about many aspects of metaphysics, essentially. And there, the idea was that the Karana Matra, right, which is basically the consciousness-centered ontology, as it is called, where everything is part of modifications of the mind, in a way, right? Or they are kind of chitta-vritti projections of chitta-vritti. Chitta-vritti means the modifications of the mind or the consciousness, in a way, right? That has been spoken about in the Yoga Vāsiṣṭha. Then there are other treatises like Vedanta Paribhasha, right, where the concept of Vishaya Sanidhya. Vishaya Sanidhya means proximity to the object, right? That has emerged with the concept of Pratyaksha Pramanatva, right? Which is perceptual validity, right? So the way you connect with the object, right? The way this, this correlation happens between who is observing and what is being observed, that is very, very important, because there is a concept of Grahya Grahaka, which is subject-object. We talk about in metaphysics in the West also, subject-object duality, right? So this concept, how do we have an interdependence between these two, right? That is something which is spoken about in Vedanta as well, right? Now, the idea is that when we are talking about, you mentioned about this one point, that what is the ontological truth that you have to give up, right? What is the deepest ontological assumption that you have kind of seen to be a mistake, right? So in one word, I would say absolutism, right? Absolutism in the sense that we have to understand that nature fundamentally has a certain contextual, very paradoxical way to do things, right? So, for instance, there are 5 different ways in which we see it very centrally, essentially. The first is that the idea of space and time, we were talking about Einstein, right? That there is no universal now, right? We say abhi, yahan pe, present, right now. There is no such concept as such, because everybody has, as I said, their own contextual or the frame-dependent time aspect, right? The second is that truth refuses this internal closure aspect, which means that if truth is mentioned with some theory, let's say, some framework, there is, as Gödel had said, there is always a way in which you can find things that defy proof from within, right? There is always a kind of outlier of sorts within that logical structure, right? Then you have this idea that things can depend or exist independent of interactions. That also may not be true, because we have seen that in quantum physics, the way the interactions happen, right? There are things called pointer states and the concept of decoherence. I think in our physics series, we had discussed about decoherence, which is about the system and the environment, how they correlate with each other. So we have to understand that there is nothing that is independent of this interaction part of things, essentially, right? And fourth, the idea that things have an identity of their own, a classical identity of their own. What do I mean by that? Basically, the idea that if something is a particle, let's say, right, it is just a particle and nothing else, right? There is no other aspect of it but the particle-like nature only, right? However, in physics, we see in the early part of the 20th century, we had seen that even particles have certain wave-like tendencies, right? And one of the classic examples, of course, is the Young's double-slit experiment, right? And if you were to make various electrons pass through the slits in the Young's double-slit experiment, then we will see that the pattern that gets formed on the screen has a lot to do with the optical Young's double-slit experiment, right, where you have what is called as an interference pattern, right? And this interference pattern comes because you have a wave-like aspect, essentially. So that means that electrons also have a wave-like aspect, right? So there is never a only particle or only wave aspect. There is always a combination of the two. And even in this, Einstein was not very happy with this. He said there are two, we are faced with a situation which is a very difficult situation. There are contradictory pictures of reality that do not by themselves describe reality completely, but together they do. Right? He said that. It's a very famous quote of his. I mean, so he was not at all happy and reconciling with this concept and with these ideas at all, fundamentally speaking, right? And the fifth, which I would like to highlight, is that uncertainties, right? The uncertainties in nature, in the things we see around us, that is very much present. Even if you were to have the best of experimental setup, the best of experimental apparatus, the Heisenberg's uncertainty principle says that nothing can, whenever there are these things called conjugated variables, right? Position, momentum, energy, time, right? They cannot together be specified with 100% certainty, right? And so this is a very fundamental constraint. It's not that हमारे पास अच्छा apparatus नहीं है, इसीलिए हम ये कह रहे हैं. It is a fundamental constraint from the beginning itself.
No
right?
matter how advanced
you are,
you cannot determine either position of a particle or the momentum.
Absolutely. And the funny part is that in nature, not only these five, but there are many other levels at which we see things emerge, right? There is this concept of emergence that comes about, which basically means that things which are there at the very fundamental level, they can build up, they can add up together in a certain specific way, such that they give rise to a layer where there are new phenomena altogether, which you could not have kind of predicted by just the things that are composing that higher level, right? So things are emergent in that way, right? And there are these things called phase transitions. We have already discussed about them as well. Now, there are a couple of things, and I think we can close this bit of the discussion, which is, so in string theory, right, we see that not only are things emergent, but even the things by themselves, what they are, right? We talked about the wave and particle aspect. People know that string theory says that everything can be explained in terms of strings, these mathematical entities called strings, right? Strings are literally like strings, but they're not quite physical strings. They're more of mathematical entities.
Like dimension ideas.
Dimensionally, they are certain placed in higher dimensions of sorts. And there are various theories of string theory, and there is also something known as the M theory, which is the, the next level of sorts. And now there is something called as a dilaton. Now, dilaton is basically talks about this coupling aspect in string theory. So why is dilaton so interesting? Dilaton is interesting because if dilaton value is less or it is more, right? Depending on what the value of the dilaton is, the theory is either called as a weak theory or a strong theory, right? In the former case, if it is a weak theory, then we can talk about things in terms of what is known as the strings themselves, right? So you have basically these perturbative string theories basically will work essentially, right? 10-dimensional strings, as we call it. And I'm sure in the physics theory, series, we'll talk about dimensionality, right? Which is a very important aspect. But if the dilaton is strong, right, is a strong aspect, then we can also talk about this idea that there are actually these strings are not fundamental. What is fundamental is something known as a membrane, right? There is like, we all know membranes, right? Membranes in our day-to-day lives, right? So the membranes themselves curl up, or they kind of, wrap around themselves to form these strings, right? The strings are emergent in that case, right? So dilaton gives rise to that. Now, there have been others, like John Webb and others, right? There are various groups that have proposed that maybe the constants of nature, which we know more regularly, not in string theory, but in normal physics, right? Like fine structure constant, right? Which talks about electromagnetism and so on and so forth. Could they also have some degree of variation in the universe, right? So if we see cosmological data from various different directions, let's say, would we see variations in that, right? So that obviously is still debated because there are many groups that have tried to disprove it and have to a large extent done that, right? But even this concept of the laws that we talk about, constants and laws, right? whether the laws themselves are supreme, are sacrosanct, or absolute, that itself needs to be scrutinized better, right? Because there is a hypothesis, obviously it's an hypothesis because we can't go back in time essentially, that all the forces of nature came from one fundamental force, let's say, and then they kind of diverged in the way they did. And we talk about something known as the gauge theories, right? The gauge theories. Now, these gauge theories show us that actually what we call physics laws, right, are expressions of certain other fundamental symmetries in nature, right? This concept of symmetry is very important. And these symmetries add up or build up in a certain manner so as to give rise to these various aspects that we see around us, be it electromagnetism, strong force, weak force, and so on and so forth, right? So again, there is also what we see and what the universe is actually being, right, are two very different things, right? In fact, in some of the cases, I'm reminded of Heisenberg, what he said, right, in 1925. He said, stop thinking about what a thing actually is, right? Because maybe we cannot know that, right? Like if I say, what is the trajectory of an electron, you will not be able to tell me that because it fundamentally is a fuzzy cloud of probabilities, right? But the idea is that how do you reconcile that then, right? So if you say that there is a certain aspect of non-absolutism there, right? It is also about how we handle it, right? And in that way, we can say that the universe is actually quote unquote pranking us, right? Because the universe is kind of defying, whenever we say something like, we think that reality is like this, right? We all say this, right? That we think this is what reality is, right? The universe almost has a laugh. I like to think of it like this, and quietly responds in what conditions and in what regime, right? Is it actually universally applicable? Probably not. Right? And so that is where we say that the dependence, the contextual nature, the actual way in which things are, right? Heisenberg said, you don't have to care about that. You just think about what you're observing in experiments, and that's it, right? So you cannot possibly go to that ontological level where you can decide what the universe actually is doing. And therefore, the book itself, right, that maybe the universe is actually pranking us, is actually not quite giving us the entire picture of what it actually is. Right? And regardless of how sophisticated the mathematics is, or the theories are, or the premises are, there have been various phases of history, of science, where it has been systematically dismantled, it has been questioned, and things have been shaken quite fundamentally at that. And so when you ask me what is reality fundamentally, right, from a purely scientific perspective, I will probably talk about it in terms of fairly abstract ideas at the moment, right? If you say what is a particle, for instance, I'd probably say it's a collection of mathematical indices which talk about degrees of freedom, right? Now that for a person, normal person who talks about particle, right? Anu, Parmanu hum baat karte hain, is so vague and so absurd, right? It's so absurd, right? आपका क्या मतलब है कि particles are a collection of mathematical indices, right? Mathematics तो है, ठीक है, but is that all it is, right? Isn't a particle a ball, like a small sphere, right? It has a boundary, it has mass, right? Not quite, right? Because even the boundary, the concept of the boundary, right? How do you define that is also very much a part of discussions within science. Right? It's not very clear. It's not like a hard boundary in that sense.
Until we
right?
try to understand electron as a cloud.
Yeah.
Until then, when a single electron.
Right. So if you say what is a spin of an electron, it's not the spin in that sense. It's a number. It's a quantum number which characterizes properties of that particle, essentially. Right. So I think that would kind of come to this idea that what you asked me, which is that absolutism is what we are going against, essentially. Yeah.
Right. So you rightfully, properly explained why the name, is quite applicable for this book.
Right. Yeah.
So now we, in your book, it seems like that we are coming to the fundamental dilemma we are having, the ontological dilemma of the truth.
Right.
So the development of quantum physics point towards an inherently indeterminate reality. So the dilemma of reality, or do they reveal a fundamental limit to the frameworks through which we attempt to know it? In uncertainty itself is not epistemic but ontological. What does that imply about the very possibility of objective truth?
Right. So this is a very important question because these are two different things, right? I mean, if you think about it, one is that there is a inherently indeterminate reality, which means that you cannot determine the nature of reality fundamentally, right? The other is saying that there are certain limitations of the theory which we are using to describe reality, right? These are two different things, right? One is ontological, the other is epistemological, as we call it, right? So now there are supporting evidences for both, I would say, in different areas of science or physics as we know it. So if you talk about indeterminacy as a fundamental thing, there are some very interesting kind of elements there, right? So you have this thing called the quantum pigeonhole principle, right? So pigeonholes back in the day were actually, where you put pigeons, and the pigeons were used for sending mail, dark, as you call it, right? So they had these coops, these small, boxes, and you used to place them, and then you take them out and, fly them off wherever you have to, right? Now, in modern times, in the West, still you have pigeonholes. You just place the letter and then, So now, if you were to have a quantum pigeonhole, basically what it means is, if you were to have a scenario where there are two boxes, two pigeonholes, right? And there are three particles, right? So if you were to think about it in classical sense, if you have two boxes and three pigeons, that would entail that one of the boxes at least has two pigeons, right? Now, in quantum physics, it is seen, and this is a very kind of simplistic way to present it. Of course, there's a much more rigorous way to discuss about it, but it is seen that if you have two boxes and three particles, no box will actually contain two particles together, right? There's this thing called weak values that you see, and there are certain places where this is just not seen, right? And this is very counterintuitive, right? Because why should there not be two in one? Because if you have to have three in two, that would mean that you have to have at least two in one, right? So this just does not exist, right? So there is a certain degree of counterintuitive indeterminacy as to what is happening, right? Then there is another very interesting thing. Many of your viewers may have read Alice in Wonderland, right? And there is this character called the Cheshire Cat, right? The Cheshire Cat.
The cat with the smile.
The cat that goes with the smile going from here to there, essentially, right? And sometimes what happens is a Cheshire Cat disappears and the smile remains. Right? Now, how does that come into this picture, right? So it is seen that in certain kinds of cases, the particle, the system, and its properties may actually be affected by perturbations in different paths, right? So let's say you disturb something in one path, the particle itself may be disturbed, but if you actually perturb something in a separate path, distinct path altogether, very strangely, even though the particle is being seen here, or its signs or signatures are being seen here, the properties are affected in the other one, right? So it's almost like the cat is decoupled from its smile. Right? The smile can exist even when the cat is not around, essentially, right? So the property and the entity, these are two different things altogether. And this doesn't make sense, because if I say you are a certain way, right? You have a certain kind of demeanor, you have a certain personality, you have a certain way to speak. I am associating that with you in the physical sense of it, right? I cannot say that Debasis's speaking style is being seen in a vacuum out there in an empty room, and Debasish himself is sitting here, right? Or his characteristics are somewhere else and he is totally decoupled from it. That doesn't make sense, right? So the indeterminacy at that level is also seen in this case. And the third thing that we need to understand is that in quantum field theory, everything is part of an emergent reality, in the sense that even particles are excitations of energy. Right? Things come out of a field, we call it as the quantum field, and then they go back into the quantum field. There is no absolutism in that. There is no absolute identity of that particle beyond and besides being energy excitations, essentially, right? Now, that is for the indeterminacy part, that nature fundamentally is indeterminate. Now, if we talk about when there are limitations of the frameworks, right? So we say there is something known as a gauge symmetry, right? So in electromagnetism and many other forces of nature, there is something called as a gauge, right? And there is a redundancy of gauge, right? If you give different values of gauges, even then it will give rise to consistent results, consistent things as such. So you can actually choose between different gauges as such. And for convenience, for various kinds of practical purposes and symmetric purposes, we select certain specific gauges or potentials, as we call it, right? So that is a concept that we have imposed. And within that, we are seeing that there is not a limitation, but a redundancy of sorts, right? Now, this is actually seen within various frameworks, and so it is not just a epistemological aspect. It has a reflection which is seen in the actual experiments as well, right? Now, in QFT, you also have things called dualities, right? There is a weak coupled and a strong coupled, or a weakly interacting, strongly interacting kind of system, and they are reflections of each other. There is a duality between them, right? In fact, there is another duality we had spoken about, which is ADS-CFT, which is that if you have a certain area, let's say, and on the boundary you have some kind of interacting system, that system will have an analog in the gravitational dynamics in the bulk which is composed of that boundary, right? So there's a one-to-one correspondence between the two, right? So there are various kinds of dualities in physics, right? Now, there is also this aspect of scale dependence, right? Things are dependent on scale, right? So these are all parts of, and in scale dependence, we talk about renormalization, which is a mathematical aspect, right, out of it, essentially. But also, again, it has connection with actual physics experiments. So you see both these things in their own ways and various evidences of this, right? Now, the question is, when you ask me this question, maybe that question itself was not the right one, right? Because I don't see the framework and the reality as separate entities at all, right? Speaking about the one is probably speaking about the other as well, right? So for instance, if you ask a fish, right, if water is wet, right, and you say that, is it because of the limitations of my fish senses or not, right? It's a moot question. It's saying the same thing, essentially, right? So for us, we are very much part of that framework and we are part of that reality, right? So this divide, right, is, I think, somewhere or the other blurred, actually, especially when we talk about observations and observer dependency and how things evolve because of participation of that observer within the universe, right? So now, when you talk about ontology and epistemology, there is a very worrying thing, however, which I just wanted to kind of point out, and then we can kind of move forward. So when I say the universe is pranking us and everything has its own relevance and there is a place for it, am I saying that there is no ontological truth? There is no objective reality? Am I saying that? Not quite, right? Yeah. I'm not saying that there is no objective reality, because of course there is objective reality, right? We are sitting on a table, we are speaking to each other through sound, which is going through a medium, right? There is an objective reality, right? So, however, what is not objectively defined or absolute is the entity by itself, maybe, but there are many aspects which have an objective reality. Like, for instance, in relativity, we have something known as space-time interval, right? There is a space and time are combined as one, and the space-time interval is maintained regardless of what kind of processes are taking place and what kind of frames we're talking about, right? So there's an invariance of that aspect, right? Then you have aspects of, for instance, the constancy of light, right? That the speed of light has a certain constant value, right? Even the physics laws, they maintain certain kinds of invariances, certain kind of symmetries and invariances. For instance, Maxwell's theories remain unchanged when we undertake certain kinds of transformations called as Lorentz transformations, right? And in Einstein's theories also, there are certain kinds of transformations that exist regardless, right? Causality is another thing where, regardless of what kind of structure, frame you're talking about, there are certain kinds of causal elements that still exist, right, in relativity as such, right? And then correlations also, there are certain aspects which still remain as they are, right? So the idea that I want to kind of highlight from this is that even though there are things that are non-absolute, but the underlying meta dynamics, right, the laws, or not the laws, but the symmetries, right, the constraints that are in place, there are places where they have an absolute aspect as well, right? Now, how is that relevant for us, right? So we were discussing earlier that if anything goes attitude is there, we have an anything goes, kuch bhi chalega type of attitude, then obviously we're not talking about society in the practical sense, right? Because then I would as much go and do something violent, essentially, and be justified in doing so, right? So there is a certain boundary that we have to draw when it comes to ethics, right? Or in terms of how do we define practically maintaining the order of society, of nature, of universe. How do we practically do things in a certain manner, right? And in Sanskrit, we have this term called ritam, right? This idea, this way of things, this order of things, right? So we cannot possibly defy that, right? So while we understand that the premise is changing, there's a lot of flux, there's a lot of movement, right? There's a lot of non-absolutism there. But practically speaking, there are many constructs, there are many emergent layers where there is a degree of absolutism, there is a degree of structure and order as well, right? So this duality, this balance, right? This is what I really like about our traditions, that this balance was always maintained, right? We didn't go and reject it outright, and we didn't only obsess on it, right? This balance is what I feel is the biggest legacy of the Indian traditions in a major way.
This
right?
indeterminacy can be an excuse for,
in a lot of things,
with
absolutely,
your ethics.
Of your ethics, of your
principles. Of course, as you explained before as well, and in that format, you also try to explain that we are quite comfortable with that.
Yeah. I mean,
that philosophy, right?
anything goes.
Dvaitavad, Advaitavad.
Yeah, so not only that, I mean, I would say there's a whole spectrum of Vedanta, right? Shuddha Advaita, Vishishta Advaita, then you have Achintya Bheda Bheda, right? Then you have Vijnana Vedanta, right? So there are many such, spectrum of possibilities of how you look at Vedanta. And when we talk about Madhyamaka school of thought, for instance, they also speak about, they go into the other extreme where they say that there is no permanence of anything by themselves. There is a contextual related way in which things emerge, right? So they talk about something called as dependent origination, right? Pratitya samutpada, and that is what kind of takes things forward, right? So in a way, we have never been people for extremes, right? And recently I wrote about how even
that's the right path.
That is I mean, I see again. So the moment you say something is non-absolute, for instance, or right, you're kind of going against your own premise, right? So if I say that non-absolutism is very important, then I'm trying to kind of make that an absolute in itself, right? And that is what Buddhaji, he kind of went ahead and spoke about that and said that once you state that as the truth, you're actually going against your own premise. Right? So therefore, you should not even speak about it, right? And therefore, sometimes in our tradition, silence, right, and the pauses are as important, if not more, than the things that are being stated or represented, right? So in a way, I would say that it is beyond representation even, right? And that is what we are increasingly seeing, that, maybe there is no unified theory of physics. Right? There is a possibility, and there's a very real possibility at that. And there are certain contextual, regime-dependent theories that exist in nature. Right, so that is a very important point. Yes.
Beautifully explained, sir. So I will come to the final questions then. If one were to internalize your view completely, what is the most radical shift it would demand in how we relate to knowledge, truth, and existence?
I think we are in an age where I have always said that, we are in an age where there's a lot of polarization, a lot of rigidities that have kind of got entrenched. And disagreements, epistemic violence. I've written about this recently. How do we become sovereign in terms of the ways we access knowledge and we represent knowledge? That also is a part of decolonization, right? I mean, we have got various things from the British, right, and before, but we have to reclaim what was actually ours, right? And if we look at things in the past, right, we have had, as we said, this balance of sorts, this very nuanced way to look at things, right? So somewhere or the other, this whole idea that whenever there is disagreement, right? So we often see that, in nature, in society, there is one group, for instance, that talks about security, structure, and control, let's say, right? There is another one which talks about freedom, autonomy, and, various kinds of resistance to, certain constructs, let's say, right? And I will not say which is which. We all know, your viewers know about it. But in politics and in society, we see both these instances, more or less, right? This is where things are in a big way, right? And they cannot see eye to eye, right? These people are very, very, anarchic. They also use this. And these people are regressive. They won't do anything, right? And they only want a very ossified, fossilized structure, basically, right? It's like a monolith. Ek cheez khada kar diya hai, usi ko rakhna hai, basically, right? Now that is a problem because both of these instances are coming from their own spaces, right? In one case, they are coming from the space of, let's say, some degree of insecurities, maybe, potentially.
Their whole identity is based on othering and,
Yeah, but we have to understand that where are they coming from, right? So one is coming from this concept of vulnerability and risk, right? The other has to talk about something known as the constraint dynamics, right? How the constraints are in place in their lives, in society, and so on and so forth. And there has been some effect of that possibly on them, right? In a certain way. Now, both are not wrong in their own ways, right? Now, so when we say this us versus them dynamics, this is representing a very primitive, right, way to segregate these two as different divisions altogether, right? But in reality, society can never be just these two by themselves, right? So non-absolutism would give you the courage to have this conversation between these two sides, right? That ye jo tension hai, there is a tension, right, between these two things. It's not a black and white tension. ऐसा नहीं है कि एक को हमने कर लिया तो दूसरे वाले का we can ignore, because there are some things of their experience also which does have an implication on society, right? So how do we reconcile these two things is a very, very important aspect as such, right? So the idea that contradictions can exist, without collapse, right? Contradiction without collapse, right? When we say unity in diversity, right? In our traditions, we have never said just tolerating them. Chalta hai, yahan pe baithe hai, baithe rehne do, right? We say we will actively engage with what they have to say, right? We will not only just sit by, right? We will actually engage with them, right? So we are not in a position of crisis. ऐसा नहीं है कि हम उनका बात सुन लेंगे तो, everything will go hunky, awry, essentially, पूरा गड़बड़ हो जाएगा. ऐसा नहीं है, right? So this idea of maintaining this tension, living with it, coexisting with it, and recently I actually wrote about this in Swarajya, right, where I spoke about this dynamics of power, right? We talk about power, geopolitics, power, and we are seeing the crisis in Iran, US, right, NATO and other EU as well. And somewhere, power has a lot to do with arrogance, right? That we are this. I mean, when you look at statements, I wouldn't name the specific leader because most of your viewers will know the leader I'm talking about. But when they say that we are going to bomb some place just for the fun of it, right? That kind of a statement is a statement in arrogance, right? Now, the interesting thing in Indian thought is we have spoken about Maya, right? Maya is this layer over this fundamental reality, which has its own ways of doing things, right? And it is very unpredictable at times. It is very, very unforeseen in the way in which it can evolve, right? And there is this concept of Mahamaya. Mahamaya, we always kind of, deify Mahamaya. And we say that please grace us with your presence of sorts. Why do we say this, right? Because somewhere this whole business of power and the foundations of power, if you see different geopolitics in the past, is fairly shaky in their own ways, right? People who have maintained ticked all the boxes, if you will, right? Very good regimes, government structures and political formations, and they have somewhere or the other still declined, right? The Soviet Union is a classic example of that, right? Many other cases such as that. So Maya, right, as a thing that you have to deal with, right, and not necessarily be very hatash, nirash over, right, ki nahi, humse nahi hoga types, right, because it will always be there, right? And in Indian thought, we not only embraced it, we also use this concept of Vismaya. Vismaya means wonderment, right? In Shiv Puran, right, verses, but they say that when somebody saw Kailasha, right, Kailash Parvat, they were full of Vismaya, right? They were full of this wonderment of what this is, right? And even Abhinav Gupta, right, he says that things should be embraced with that sense of, wonderment of sorts, right? He talked about rasa, right, aesthetics essentially. And he said that Shiva, right, Shiv Shakti has to be approached from that rasa aspect as well, right? So that is philosophy, that is spirituality and metaphysics, but in physics also, in science as well, we are seeing that there are times when we are just amazed by what we see, right? Things can tunnel through barriers, right? You can teleport things from one place to the other, right? Star Trek, not quite Star Trek, but there is a teleportation in the quantum side as well, right? Why does this happen? How do you explain this, right? So you will have a theory, but very soon it has been seen over time. There is always this one aspect that comes in some experimental result, right? Which will contradict what you have just said, right? And you or somebody may say that you are being cynical here. You're being skeptical to the last mile. But this is something we are seeing over time, right? This systematic breaking of absolutism, right? पहले हम सोचते थे कि time absolute है, laws absolute है, things are either particles or waves. These are all things that we assumed, right? All of them have been systematically broken over the last 100, 150 years, right? Now where we are, we don't even know where we are going with it at times, right? There are candidate theories of everything, as we call it. Even string theory has not been empirically defined and conclusively established per se, because many aspects are still not proven per se. But is that a failure on our part? Should we take this as something which is negative? My hypothesis, you can call it, or my position is, why don't we embrace that? Right? Why don't we embrace the possibility that uncertainties are hardwired into nature itself, right? And maybe it defies categorization altogether, right? We talk about category theory in higher dimensional mathematics, right? Categories, maybe there is no one category that can define it, right? And this is something that our thinkers in the past have said, and we are seeing in the scientific context. So maybe that is the way we should take, right? And maybe we should laugh about it as well, right? So that is why this idea of pranking us, pranking is a very strong word. It is almost like there is an intent of the universe in doing that, right? But obviously, in our traditions, we talk about it in terms of wonderment, as I said, right? But there is something which defies things in a very unexpected way, right? In a sudden way, in an abrupt way, in a non-linear way, right? And that bewilderment, right? We always say that the scientific journey of a child starts from literally when they are children, right? In fact, they're better at science possibly in terms of their natural inquisitiveness, for instance, than when they are trained through certain kind of formalisms and paradigms and so on and so forth, right? So if you can understand that this degree of curiosity, right? Ye aisa kyun hai? And can I maybe not explain it entirely? And I'm fine with that, right? कि मैं पूरी इसको नहीं समझा पा रहा हूँ, but that is okay. That's also part of your understanding of the nature of reality, right? So somewhere, either you can be skeptical, cynical, and be like, I'm in a tense situation and I don't know where we are going with it, or you adapt and you work with the things as they come along. I'm not saying discard the theories. Of course, you cannot. As physicists, as scientists, we have to work with the theories. But we may have to understand that maybe the theories are, number one, not sacrosanct. Number two, they may not be absolute. And number three, there may be times when you have to contextually adapt things around and admit that we have to be humble about it, right? That maybe we do not have the answers for everything, essentially, right? So this I hope with this book, right? Well, my main hope with this book is that, and this book doesn't talk about metaphysics or philosophy all that much, obviously the foundations of science as such, but this whole question of what we regard as the reality as we know it, right? Reality aisa hai, right? Or reality वैसा है, या हमें पता है कि एक spectrum of realities है. Even that statement, right, may be false in certain levels, right? In our Indian tradition, we talk about Chatushkoti, right? We talk about the proposition, negation, double conjunction, double negation, right? In Jain philosophy, we talk about the 7-pointed logic structures, right? We've already discussed that.
Yes.
So we are talking about those places where even that does not work, right? And so logic and reasoning, right, while we should never compromise on that, right, has its own limitations. Either because the subject of your reasoning has its fundamental limitations, or your reasoning frameworks themselves have certain limitations, right? And we have to move ahead with that humility, with that open mind of sorts, and explore things as they are. Because in India, we believe in Satyameva Jayate, right? And truth often is very contradictory, very paradoxical, right? And very, very counterintuitive at that, right? But that is the way of our country, of our civilization, and we should stick by that.
Wow, wonderful. I mean, when I start the discussion, what we started from, the physicist, they started doing experiment with that curiosity,
right.
And they started to find the rigidness of the universe.
Yes.
But step by step they find that
it's not,
it's not that rigid.
You have to
at
negotiate
all.
with that.
Yes,
right?
maybe they are now trying to accustomed with the Indian philosophy, theology as well.
And in fact, I say one thing here, that it is because of their philosophies somewhere, some of the philosophies, I'm not going to generalize it, but some of the philosophies in those places have been exclusivist, right? They are all about us versus them before the scientific side came into the picture. And I always say that the philosophy of the people, right, also guide their various pursuits, right? Be it science, be it geopolitics, be it societal kind of dynamics, it does inform that, right? So if they have that premise, right, obviously their way they will move ahead also may have reflected that to some extent, right? The unfortunate thing is, even though we had a different kind of premise, we still went with that because of various reasons, one being the colonial aspect, right? So anyway, so my hope is that we will go beyond that.
Yeah, definitely.
I mean, and we will decolonize.
The discussion would start from there, and it turned out to be, the path to view the complexity.
Absolutely.
And make the right shift toward understanding reality. What is the fundamental problem we are having as a nation state on paper.
Yes.
But definitely.
I call it a cognitive republic.
Cognitive republic. That's a beautiful term. Right? I mean, I am trying to say it's a civilizational state.
Yes, civilizational state which reflects its metaphysics, its philosophy, and we move ahead with that understanding. right? That is
Great,
what is
sir.
important.
Thank you so much.
Thank you so much. Yeah.